Hey guys, so solving the TP on grids problem, which is the problem number TP of 10, this is the problem. I'll be solving, I think this, and we'll try to solve this also. Let's see. So here, problem says that we have a grid and we have to calculate the minimum sum, I think, na? Minimize the sum of numbers along its path. Okay, first write it. Calculate minimum sum path. Also, if you see, we can't use greedy. We can't use greedy. Why? Because it is not uniform. Numbers are not uniform. So there will be some point where you might lose the minimum sum or get the max something that would be. So there we come on recursion. So recursion may be used because we have to choose all possible ways. Now, okay, so now what we are gonna do, we're gonna write the recursive function. What do we need? We need m is equal to the grid of size n would be equals to size and solve, return, solve. So we're gonna pass grid and okay, down and right, okay, down and right, similar type of question. Left to top right. What? Top left to bottom right. Okay, same. I got it. I got it. So I have to reach from fixed point to fixed point. Okay. Now -1 and n-1. Okay. Now write the solve function. What the solve function would? We have a grid. Pass it. We have I. We have j. Is starting from, let's say, end. Okay. Bottom right position. Okay. And write the base condition, obviously. What is the base condition? Base condition would be when you reach the destination. Okay, you have reached the zeroth position, 0 0 position. Now you have reached the 0 position. What we do? We just include that count. Here we just include that position. So grid of grid of uh, ij, obviously 0 0. So that thing. It may be like I less than 0, obviously 0, and greater than I less j less than 0 will be 0. If I less than 0, or let's say j less than 0. What does it mean? Return, wait, what do you need? Solve function ij will give us the minimum sum onto a path, ij positions. So we have to get the minimum. If we make it like int max, it will not be in our solution, obviously. But it's not possible. Like, not possible if you put it 0. 0 can be minimum also. 0, that was count. Here you have to put, since it is minimum, is needed. So included it and all that. Here would be int max. Now, okay, yeah. So we can have, we have to go to the up. We go to the up. It will be like solve for grid I minus 1 j int down solve grid ij minus 1 return up plus, why it is down, it should be down, it should be left. Yeah, no, it should be minimum. Okay, yeah, in up you were moving up, but you have to add that thing where you are going up, like you are going from bottom right corner to the, let's say, top left corner. So when you are going up, then you have to add that thing, get the minimum. All right, so grid of I j plus move to the position you want to move. So now it will work. What? Oh, what is written? My int is now. Oh, oh, okay. Um, Signed integer overflow. Okay. Hmm. So the error was because we have put int max. Int max was not it cannot be expressed in the int data type. I think int max -1 might work. No. So to use something like 1A9, it will work. Yeah. So now this will not work though because the 200 constant is given, because if you see there is two choices to go here or here in every, so 2 to the power, let's say, I mean n is the time complexity, but now you can improve this by uh, using what? Obviously, you know, we know, everyone knows. Proof. Okay. अब है vector in vector int dp size, let's say m, and obviously m because m -1 after we are doing, and vector int n and p all will be -1. So pass that dp and copy this thing. Pretty easy thing, na? Not. Okay, so now if dp of ij not equals to -1, return dp of I and j. And before that, we have to just save this thing to dp of ij. Okay. Hmm. See, you will see, it will work. There is no problem with this problem. We can improve this. We can improve this thing also by using this thing also by using tabulation. So it's pretty nice to do tabulations and all. Oh, you want to tabulate it? Pretty good. However, int let's say I'm not writing dp, so int I and j. Okay, and making like for int I 0 less than. Okay, okay, so yeah, we used I, so let's k k less than I is then equals to I, obviously. K plus plus, and let's until j, so let's say L. Okay, L0, L less than equal to, let's say, j, L plus plus. And then what we are doing is that we are, if k0 and l is 0, not return, just t of k and l is equal to grid of k and l of s. And there is, if you can make int up 1 e9, okay, and left is also 1 e9. Why we're doing this? Because now you will understand why we have done this. K greater than 0 to something that is up would be grid of k and l plus t of -1 and l, okay, and if l greater than 0, left would be grid of kl plus kl minus 1, and after that you have to just save it. Grid of k and l would be our minimum of, sorry, t minimum of up and obviously left. After that, we return t of I j I plus 1 minute plus 1 minute. So don't need this thing first of all. I think okay. Okay, bro. Submitting too frequently? We are not. There is some error might be. Uh, okay. Mm. Hmm. Sorry. Uh, Not sorry. Yeah. Oh my. Looks तो ठीक ठाक ही. Hmm. Done. Huh. Uh, well, I don't. Oh, oh. So see, there is very minimum changes that we have done. Written, we haven't put. Also there is else statement. Why we have put this else statement? Because it was coming here up after this, it is moving to this line and it is making this thing and again this thing. This is not logical, this is not correct, obviously. You see nicely. Write only logical code, the code which does matter. Do not write anything you are getting inside your brain. No, have to write stuffs which is logical. Now let us try this problem also. What is this problem says? We have a triangle and it is like this. Yeah. So you have to move either to the down or I think diagonal. Minimum path sum from top to the bottom. You have to reach to the bottom, not the disposition. It's not asked to do that. For each step, you may move to the adjacent or more normally, if you are on index I on a current row, you may move either I or plus. Yeah, so pretty simple. We have to move like down or we can move to the diagonally we can move, but and have to get the minimum path sum. Does this look same to the previous question? Yeah, it is similar to the previous question. It does look similar to the previous question. Just here is a triangle type structure. Okay, if you want me to write it and all these things, let's say, so this is like this. Just ask to move from here, you can move like this, all this. Move to this position, like this position. Either of them. This, any position. You have to reach here only. That is what it is asked in this problem. Okay? Yeah. Oh, yeah. So, yeah. So what we can do is that we can start from here because it is fixed, but it is not fixed. You come here, you can come here, you can come here, you can come here, you can come here. So 0 to 0, we have to reach from 0 to 0 to what do you call this position? Like uh, what it is like, say n minus 1 or m minus 1, m minus 1, let's say reach to m minus 1. That is the thing. Okay, so let's write the code. Okay, so copying some of the parts. This thing, obviously, it will be like a triangle, and we can write return solve for triangle m and m minus 1 and n minus 1, obviously. And now you have to just int solve. Let's int I and int j. Base case, what would be? Similar to the previous one? Okay, so no. It's not the base case. Now you and not have to from from 0 0. Okay, yeah. So now we can pass some minus one. If we reach the what is m minus one, let's say. Here m is m minus one obviously. Uh just pass m or pass. So if we reach m minus one, we have to return that sum also. So triangle of ij. So so you are moving like this, let's say this, this, and you come here only. There is no going to the position negative or something. I know something. Here you will move to this. But in that position, what we are doing, if you move, we go to the less than zero. And here also. Here not. You are going down. You will reach the destination. Otherwise, getting my point. So it doesn't require that thing like I less than zero and all that. And now you have to write the recursive function for moving down and moving diagonally. Yeah, so in down would be, I think, to write for triangle. Ah, okay, pretty simple. And solve for down. Yeah, so I think it will be like I plus 1 and j diagonal be, yeah, similar. Just one thing for diagonal, it will be like I plus 1 j plus 1. And at last you have to return the what, like the minimum path or something, or the maximum, um, minimum path sum. So return d comma diagonal, it will be like minimum. And let's see whether it is okay or not. Okay, this stuff is missing. Oh, m and n, it will be like this only. It does work, but will not work for so-called recursive function will not work because of the sub-problems is there. What I have told that there may be a sub-problems which may be in this problem which will which will be solved like by memorization and all, and the time complexity reduces, like it reduces drastically from 2 to the power something where I think um yeah 1 2 3 as like 1 2 plus 2 n. That's how it will be. I think um n to n plus 1 by 2. Yeah, to put n into n plus 1 by 2, it would be like the 2 to the power exponential obviously to be n to n plus 1 by 2. But and this like the memorization and tabulation thing will make it big of m into n, or it would be like yeah because of why, because sub problems are solved by sub problems are already solved, so we just return that thing. What do you do in a memorization? Make a vector and all these things we will be copying because uh, why do the stuffs which is time taking and does require you to, I will not do stuffs which is like this is what takes doesn't take brain. Yeah, what doesn't take you enough use of brain, do not do that thing. It's my request because it's not like then it would be done by lots of people. But okay, so yeah, so this approach of recursion and tabulation, recursion and memorization would be what type of thing? Top down or bottom up approach? So tabulation is bottom up from 0 0 we start like no from size 0 0 yeah so bottom to up, but from recursion memorization it is from top to down, from top to down it is bottom up like this. Hopefully I've understood my, let's just submit it because it would be okay. What? Line 5, yeah, articles -1, return that dp of I and j. uh, huh, why it is showing like okay, so it will not work. We have to do like tabulation method. It is not working. Over okay, heap buffer overflow. That means space optimize it like this, got it. So yeah. So you have to do something called tabulation. Ah, so just remove it, bro. You want me to tabulate it now? Let's tabulate it, no problem. So int set t. Oh, I need this thing. I don't need this thing though. Okay, and okay. So int, let's say t would be like m and like n, cause m minus 1 obviously, and we need two loops or int. Why would I write again and again? We have this thing, copy this thing. Yeah. So return some stuffs. Okay, make it k or some k to. I think let's say we have to. Mm, yeah, not k or something. It will be like -1 and it's like n-1 l, let's say equal j. Okay, now making our two loops, and obviously it will be like I, and it will be like j, like I j stay. Okay, to make it to I l, or this l j, um, uh, make it j j. So um not returning j, we obviously -1, like -1. First check it. Okay, triangle. This thing is good. This thing is good. This thing is okay. Got it. So it will like wait. In tabulation also from 0 0, the base case would be like when it reach, let's say m-1, and that position just add the stuff. Do not need this thing. Also this thing. We need int. Okay, now this thing is also not required obviously. Int and yeah, so be like +1 I think. And would be like +1 +1. Okay. Mm, yeah. So see, let's see. Okay, there is something error. Variable length array. This error is showing too much time. Like, oh. um, Okay. Yeah, got it. Uh, uh, ah, what? What is this? Um, not a little bit diagonal though, but runtime error? Wait, wait.